Hello wonderful person, this is Anton, and today we're going to be discussing a relatively recent study that for the first time ever might have officially identified remnants of the first stars in the universe. The stars we often refer to as population 3 stars, which in essence represented the first ever objects that were able to produce nuclear fusion, leading to the first starlight in the entire universe, and very likely dramatically changing the universe around us, with the discovery and the results reported in the study in the description below. Something that the scientists have actually been looking for a very long time, and something that technically the James Webb Space Telescope is supposed to discover in the next few years. It hasn't yet, but that's one of its main goals. Ironically, this is not coming from the James Webb at all, and instead is coming from the Very Large Telescope currently operating in Chile, part of the European Southern Observatory. In this case, using an instrument known as X-Shooter that's able to analyze light of very bright distant quasars, some of the brightest objects in the entire universe. And usually, as this light passes through various types of gas, it changes the light just a little bit, very often producing specific spectra, usually linked to various elements that we find in outer space. And though in many cases the light from quasars doesn't interact with anything specific, in some cases it also passes through various nebula or various large clouds left behind by something else. For example, left behind by some of the first supernova that occurred billions of years ago. And specifically some of the most unusual supernova that very likely happened approximately 13.5 billion years ago. Now there's another older video on the channel that kind of explored this idea a little bit more, but these initial first stars that essentially only contained hydrogen and helium in them most likely produced very unique and very different supernova. It's not entirely clear what sort of supernova just yet, but in some cases these might have been supermassive stars, possibly even thousands of solar masses in total. But obviously not all of them were like this, and some might have been much less massive. The important difference is that these stars contained primordial materials, mostly hydrogen and helium, with tiny amounts of lithium, nothing else. And it was the gas from these stars that then started to spread across various galaxies and ended up producing all of the other stars. At some point, after 30 to possibly 40 such supernova, that's when our sun was born as well. But these population 3 stars were very likely in existence for just a fraction of the entire period of the early universe. As a matter of fact, they might have only existed for a few thousand, maybe maximum a million years. At least some of the more massive ones. There might have been some stars that could have been a little bit less massive and thus survived longer. Now these less massive stars would obviously still be very different from everything we have today, but at some point they would also start transforming and possibly go supernova, resulting in a typical molecular cloud, but in this case with very specific, very unique composition containing a very specific fraction of various early elements, something that the scientists have calculated and predicted before, but have never seen anywhere. For example, some of these clouds would have high abundance of carbon and oxygen, a little bit of magnesium, and would have a very specific silicon to iron ratio. And if you compare it to various clouds we find in the modern universe, the ratios would be quite different. And so in these very early galaxies with very early supernova and extremely ancient stars, the overall ratio is expected to be kind of the same. But up until this point, all of this was mostly theoretical and basically just based on predictions. It has never really been seen. And once again, because we believe these stars would exist for a fraction of a lifetime of a typical modern star, representing just a tiny frame in the entire timeline of the universe. So basically, so far, it's been just really hard to catch them. But what's important to understand here is that they didn't really all go supernova all at once. Some survived much longer, and possibly even up to 1 to maybe even 2 billion years since the beginning of the universe. And that's of course mostly because some of these stars would be a little bit less massive. But there's another really important fact that we need to talk about in regards to these first stars. When they just started appearing, all of the gas in the entire universe was neutral. In other words, the universe contained what we refer to as neutral hydrogen. Now here it says the universe was transparent, but this generally creates a bit of a confusion when it comes to astronomy. So for the first 400 million years or so, the universe was transparent to some of the most ancient light, especially the one that we now refer to as CMB. But no other light, specifically high energy light, could pass through anything. Because of very high amounts of neutral hydrogen, it was impossible to see any starlight, with the entire universe appearing sort of murky and sort of cloudy. and at certain distances it was probably impossible to see any stars. But these first stars were already forming, and as they formed, they began what we refer to as Reionization period. We don't actually know how long this lasted, and what exactly was responsible for reionizing the entire universe, so we don't actually know if it was stars or possibly quasars, or basically black holes, but we know that it happened, and we know that it happened within a few billion years or so, resulting in the gas that we have today, and specifically, at some point allowing all of the starlight to pass through and for the universe to no longer be opaque. But that's one of the main reasons we're unable to see certain stars at certain distances, and why it's been so difficult to pinpoint and discover these ancient stars. They're sort of hidden by the layer of very thick neutral hydrogen. And so all of the previous theories and previous investigations mostly tried to figure out what signs of these stars can we find out there in order to confirm their existence. And of course the biggest sign would be what's left behind after they went supernova, the molecular clouds. But even here the scientists had trouble finding them because this is still really far away, and because there's an extremely limited way we can see that far. Luckily, we also get some of the earliest light coming from various quasars, which does pass through a lot of these various clouds. And so for this particular study, the scientists used VLT to investigate 54 such clouds, with some of these clouds possibly created by population 2 stars or second generation stars, but the scientists here hope to find at least some of them would be from these first stars that appeared about 13.7 billion years ago. Now generally these clouds don't actually even exist for that long, and most disappear within just tens or maybe hundreds of thousands of years, none existing longer than 1,000,000 years, with most of this material being recycled in new stars, which then will have their own supernova. But as I mentioned before, population 3 clouds would contain a very specific ratio, and in theory would also possess a lot more mass, and thus be slightly better visible. And out of 54 clouds the scientists looked at, 3 of them seem to contain the predicted values from all of the previous studies, and all of these 3 clouds existed between 1 to maybe 2 billion years after the beginning of the universe. For example, they all contained elevated amounts of magnesium and silicon, expected from various low-energy supernova, which is kind of what we think happens to these first stars, and the right amounts of carbon and oxygen as well. And if the study is correct, and if this is indeed what the scientists have just discovered, it means that some of these ancient stars survived for up to 2 billion years, with some maybe even surviving longer. And in theory, some of the smaller stars, the ones that never went supernova, could still exist even today, especially if their total mass is lower than about 70% the solar mass. Or if we find some kind of a red dwarf that appears to be entirely made out of hydrogen and helium, that's a telltale sign that this is a first star that just never exploded. And there have been some implications about previous discoveries, but in the end there's just not enough evidence that these stars exist. Although one of the previous videos you can find in the description talks a little bit more about these ideas and some of these discoveries and provides a little bit more evidence. In the end, this is still a pretty exciting discovery, and actually a pretty big discovery, because now the scientists might be on the path to physically find these stars by using telescopes like the James Webb. As a matter of fact, by zooming into some of these galaxies, and by trying to pinpoint the exact location where some of these stars might still exist, in the next 10 years or so, we might finally confirm their existence, and thus confirm a lot of previous ideas about the Big Bang. But at least for now, this is already a pretty big evidence, and would be kind of difficult to explain otherwise. It would be very difficult to explain the existence of these clouds unless they were produced by some kind of a very primitive first star. Anyway, we'll talk more about this once there's more confirmations or potential additional discoveries. At least for now, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.